Hey, Mike Thompson here. If you are a teacher or a flight instructor, I want to make you aware of this book. I wrote this book for flight instructors, but it applies to teachers in general. It talks about the teaching and learning process, and what I'm emphasizing here is the fact that just telling things to students is not teaching. To be an effective teacher or flight instructor, we need to build a personal relationship with that student and work with them based upon what they need. So you can find me on Amazon, and see you next time. I screwed up the ending. Telling is not teaching. Try to find it at Amazon.com. Boy, oh boy, oh boy, I'll tell you what, I'm working hard out there. I came running over to the studio. There's a high pressure altitude. It's hot outside with high humidity, and I'll tell you, I am not performing as well as I normally would if there were a lower temperature, a lower pressure altitude, and lower humidity. Folks, what I'm trying to describe to you here is density altitude. Hey, welcome back to the Epic Flight Academy and the Private Pilot Ground School. My name is Mike Thompson. Our topic today is density altitude. Remember, you are not going to understand the gist of this unless, number one, you're working through our online Private Pilot Ground School course, and number two, you're using this video as a parallel to that content, and then thirdly, you review the density altitude material with your flight instructor in a one-on-one ground oral. Now let's get back to that density altitude. Whew, boy, oh boy, you know, I was doing the same thing I do every day, just running over to the studio, but today for some reason, man, I'm exhausted, I'm sweating. What's the reason? The reason was high pressure altitude, high temperature, and high humidity. That caused a high density altitude, and I wasn't performing as well. The exact same thing will happen to your aircraft. Your aircraft may be at the same airport, and that airport elevation has not changed, but the density altitude at that airport might change with pressure altitude, temperature, and humidity. So one of the important things for us as pilots is to determine what exactly is our current density altitude. Now, in order to do that, we would like to take you to the Pilot's Handbook of Aeronautical Knowledge, commonly known as the PHAK. Now we are going to be in Chapter 11 and specifically looking at Figure 1122. That's what's shown here on the screen behind me. On this chart, we can determine our exact pressure, temperature, and density altitude. When we look at factors affecting the performance of your aircraft, in fact, there are many, but I'd like to make you aware of the two main factors that affect your aircraft's performance. The first one, density altitude. The second one, your weight and balance. Those are the two main factors affecting your performance. Well, today we want to calculate your density altitude. So how do we do that? We're going to use this chart from the PHAK, and we're going to do this in 3 simple steps. Now, step one, a conversion. What are we converting? In the PHAC, we're going to look at the sample problem number one, and we need to compare the pressure altitude to the airport elevation. The way we do that is we find the current altimeter setting. Now take a look at the example. Our current altimeter setting is 3010. So what we're going to do is we're going to come in on the right side of this chart, and you're going to come down to where you see the green highlight, and 3010 tells me minus 165. Therefore, it is necessary to subtract 165 from the airport elevation, giving a pressure altitude of 5,718 feet. That's step one. You see, that wasn't too tough. Step two is just as easy. In step two, I'm going to come across the bottom of this chart, and I'm going to find the current OAT. No, that's not the oatmeal I ate for breakfast. OAT is outside air temperature. Notice in our example, it's 70 degrees Fahrenheit. So I come to my chart and I see both Fahrenheit and Celsius scales. I enter at 70 degrees Fahrenheit or 21 degrees Celsius. Now what I'm going to do is come straight up the chart from that temperature to my current pressure altitude. What's my current pressure altitude? Aha! That's why we needed step one. Remember, we already calculated it. 5,718 feet. So from the temperature, I'm going to come straight up to 5,718 feet. Notice, as I'm coming vertically in this chart, I've got these black slanted lines. If you look closely at the chart, you see those black slanted lines are labeled pressure altitude. And notice where our red line example comes up to. Approximately 5,718 feet. You see how we came up the red line just shy of our 6,000 foot pressure altitude there? Okay, there you go. Now you've pretty much got it. So step one, I had to convert. Step two, I had to find my temperature. And step three, I came up to that pressure altitude on the chart. Am I there yet? Yeah, pretty much. Now it's simple. I'm simply going to take a straight edge, that's a piece of paper, my plotter, the edge of a folder, and I'm going to go from that 5,718, and I'm just going to make a perfectly straight line, and you can see it in the example, right over to the left side of the chart. Voila, I'm done. I got it. Read your density altitude down the left-hand side of that chart. And notice it looks like it's pretty close to, right about 8. The 8 means 8,000. Okay, what is that really telling me? That's telling me that even though my airport elevation is 5,883 feet, with a pressure altitude of 5,718 feet and a temperature of 70 degrees Fahrenheit, the airplane feels as though it is performing at 8,000 feet. That's over a 2,000 foot difference. the airplane will perform as though it were actually at the higher altitude. The air is less dense. The performance will be not as good. And it was just like me running over to the studio. On any given day, I walk over here, normal altitude, normal humidity, normal temperature, I'm fine. Today I came in, I'm huffing, I'm puffing, I'm dripping in sweat, and your airplane is kind of similar to that. It's going to have to work hard, and it's going to get less performance at higher density altitudes. So you can see, I hope, from this short video why density altitude is critical. So you understand when we say that the two main factors affecting my performance are, who can fill in the blank? Number one, you got it, density altitude. Number two, that's right, weight and balance. Be sure to review this with your flight instructor, folks. That's it for today's lesson. We'll see you next time.